Today's video is on analytical geometry. Now, analytical geometry is geometry on a Cartesian plane. Analytical geometry works with the distance formula, it works with midpoint, and it works with the gradient of a line. We also talk about the angle of inclination in analytical geometry, so I'm going to be covering all of that in this video. I'm going to be doing it step by step so that you can follow along. In future videos, I'm going to be doing past paper questions on the analytical geometry questions so that you're able to practice what you'd be able to expect in an exam. The first question gives us the points P, Q, R, and S. It says plot the points on a Cartesian plane. So P being -2 and 6 could be up here somewhere. So I'm going to say that this is -2 and 6. Q is 3 and 6, so they share the same y value, but it's 3. So I'll put it over here. This is point Q, and this is 3 and 6. R is 3 and 1, so I'm going to put R at 3 and 1. And S is -2 and 1. So S is -2 and 1. Now I'm going to draw. All right, so now I can kind of see what I'm working with. So I'm working with a square type shape. The first question says, calculate the length of PR and QS. Calculate the length. Now remember, if we're just talking about length, we have to remember that length is always positive and that you just need to write units at the end of your length. All right, so we want the length of PR. So what I suggest that you do is you just label your coordinates, x and y, x and y, x and y, just so that you substitute the correct values in the correct places, because sometimes it gets a little bit confusing, and if you substitute the incorrect values in the incorrect places, then I'm scared you're going to get it wrong. If we quickly talk about the distance formula, the distance formula will be the length of a line. Okay, now the length of a line, you'll have, let's say for example, the length of AB. Now you can say XA minus XB or XB minus XA. It doesn't matter which order you put the letters in inside the brackets, provided that whatever you do to the X, you do to the Y. So if it's XA minus XB, then it's YA minus YB and vice versa. So if I'm looking for the length of PR, I'm going to have a super long square root sign. That's too long, but anyway. XP minus the x of R, all squared, plus the y of P minus the y of R, all squared. Now remember, if you have the wrong formula, you're going to get 0. So the order of the subtraction and the addition is what's important. All right, so it's subtraction inside the brackets and addition outside the brackets. Now I have an easy way of remembering it, is that inside the bracket, it doesn't matter whether you have a positive or if you have a negative. If you're squaring it, it will result in a positive. Okay, so the brackets can be negative because they're being squared, but if you're subtracting numbers, you're going to possibly have a negative answer, and you can't square root a negative. So that's kind of how I remember it, is that the negatives can be inside the bracket because the negative squared is still a positive, but the negative can't be in between the two brackets because that could result in a negative answer, and you can't square root a negative. So now I'm simply going to substitute in. So PR is equal to the square root of x of P is -2 minus the x of R, which is 3, that's squared, plus the y of P, which is 6, minus the y of R, which is 1, and that's also squared. Now I'm going to type that into my calculator, and therefore PR is going to equal, now if you simplified it before typing it into your calculator, you'd get the square root of 50. However, you can just type it straight into your calculator and get a simplified third answer, and that will be 5 root 2, but it's a length, so I'm just going to write units next to it. Now I'm going to calculate the length of QS. Now you can actually see, I just want to point out here, PR is actually this diagonal length over here. All right, so we've calculated that diagonal length, and now we're going to calculate QS, which is the second diagonal length over here. All right, so we have QS equal to, and I'm going to just write out the whole formula, the square root of XQ minus XS all squared plus YQ minus YS all squared. Now remember, you could have XS minus XQ so long as you have YS minus YQ on the other side. So QS is equal to the square root of the x of Q is 3 minus the x of S is negative 2, so I'm putting that into a second bracket, squaring that, plus the y of Q, which is 6, minus the y of S, which is 1. And that's squared. Therefore, QS is equal to, when I put it into my calculator, I get an answer of 5 root 2 units, or the same as the square root of 50. The next question says, determine the midpoint of PR and QS. This question is asking for the midpoint of the line, which means that we're going to take the x-coordinate of each end of the line. We're going to add it together and we're going to divide it by 2, which is going to give us the middle of that x-coordinate. And then we're going to take the two y-coordinates, do the same thing, add them together and divide them by 2 to get the midpoint, because midpoint is directly in the middle of the two coordinates. So if we're looking for the midpoint of PR, we're going to take the x of P plus the x of R, and we're going to divide them by 2. And then we're going to take the same order, the y of P plus the y of R, and we're going to divide it by 2. So that's going to equal the x of P, which is negative 2, plus the x of R, which is 3. That's going to be over 2 because we're dividing it by 2. And the y of P, which is 6, plus the y of R, which is 1. And we're going to divide that by 2 as well. So now we'll have a set of coordinates. Minus 2 plus 3 over 2 is a half. And 6 plus 1 is 7 divided by 2, which is 7 over 2. Or we could write it as 3.5. So there we have the midpoint of line PR being a half and 7 over 2. Now we're going to calculate the midpoint of QS. And that's going to be the x of Q plus the x of S divided by 2. And the y of Q plus the y of S divided by 2 as well. All right, so the x of Q is 3 plus the x of S, which is negative 2, divided by 2. And the y of Q, which is 6, plus the y of S, which is 1, divided by 2. So that gives me 3 plus minus 2, which is 3 minus 2 over 2, which is a half. 6 plus 1 is 7 over 2. And now what we can see is that we actually have the same midpoint of these two lines. So both of the lines have the midpoint a half and 7 over 2. The next question says, determine the gradient of PR and QS. The gradient of a line remains constant throughout that line. We have a positive gradient, we have a negative gradient, we have an undefined gradient, or we have a gradient of 0, all depending on what type of line we have. Is our line increasing? Is our line decreasing? Is our line vertical, or is our line horizontal? And those all determine what the gradient is going to be. In order to work out the gradient, we work out the gradient as change in y over change in x. So it's the y coordinates subtracted from each other over the x coordinates subtracted from each other. Okay, so to calculate the gradient of these two lines, we're going to start with the gradient of PR. And that's the change in y over the change in x. So it's the y of P minus the y of R over the x of P minus the x of R. Now remember, we could also say the y of R minus the y of P over the x of R minus the x of P, provided whatever we do at the top, we do at the bottom. So whichever order the y's are in, the corresponding x values need to be in the same order. So the y of P minus the y of R. So 6 minus 1 over x of P, which is minus 2, minus 3. So 6 minus 1 over minus 2 minus 3, which is 5 over negative 5, which gives me a gradient of negative 1. So that's the gradient of PR. Now I want to calculate the gradient of QS, and that will equal the y of Q minus the y of S over the x of Q minus the x of S. So the y of Q is 6 minus the y of S, which is 1, over the x of Q, 3 minus the x of S, which is negative 2, so I'll put it into brackets. 6 minus 1, then I have 6 minus 1, which is 5, and 3 plus 2 is 5, and 5 over 5 is positive 1. The next question says, what does your answer in D tell you about the lines PR and QS? When working with gradients in analytical geometry, we have to remember that parallel lines have equal gradients, so the gradients are the same. And in a perpendicular line, two perpendicular lines, so where the lines meet at a 90-degree angle, the product of the gradients is negative 1. What do these two answers tell us about the line? Well, PR is perpendicular to QS. Why are they perpendicular? Because the product of the gradient of PR and QS is equal to negative 1, because negative 1 times positive 1 is negative 1. The next question says, discuss what type of quadrilateral PQRS is, giving reasons. Well, what we've worked with so far are the diagonals, and these diagonals are equal to each other. These diagonals are perpendicular to each other, as in they intersect at 90 degrees, which tells me that I'm working with a square. If E is the point 5, negative 1, are the points PR and E collinear? PR and E. Alright, so if we're looking at PR and E, for them to be collinear would mean that they would need to lay on the same line. So collinear points mean that they lie on the same together linear line. They're on the same line together. Now, if they're collinear, that means that the gradients will be the same. Okay, we have the gradient of PR, and that gradient is negative 1. So for these points to be collinear would mean that E would be laying on that line, which means that I would be able to calculate the gradient of RE or PE to see if it's the same, if it's equal to negative 1. They've also given us the coordinate of E, which is 5 and negative 1. So now we have the coordinates of R, we have the coordinates of E, which means we can calculate the gradient of RE to see if it's the same as the gradient of PR. So this is my X and this is my Y. So the gradient of RE will equal the change in Y, so the Y of R minus the Y of E over the change in X, which is the X of R minus the X of E. So the Y of R is 1 minus the Y of E, which is negative 1, over the X of R, which is 3, minus the X of E, which is 5. So 1 plus 1 is 2, and 3 minus 5 is negative 2. So 2 divided by negative 2 is negative 1. So therefore, the gradient of PR is equal to the gradient of RE. So therefore, P, R, and E are collinear. Now we're going to be finding the equation of the straight line. In grade 9 and grade 10, you've used y equals mx plus c or y equals ax plus q. They both mean the same. And if we talk about those formulas really quickly, the m is the gradient and the c is the y-intercept, or where the graph cuts the y-axis. So now I'm just going to introduce a new form of that formula, or a new way in which we can determine the equation of a straight line. And that is y minus ya, or y1, is equal to m into x minus xa, or x1. So what we need in order to determine the formula is we need the gradient, and we need an additional set of coordinates, or an additional point that we can substitute into our formula. The question says, determine the equation of a straight line which passes through the points A, 3 and 7, and B, 10 and 21. So I'm just going to quickly label x, y, and xy above my coordinates. For both of these methods, or both of these equations, we need to determine the gradient. So we're going to start by calculating or determining the gradient of line AB. So that's the change in y over the change in x. So the y of A minus the y of B over the x of A minus the x of B. So that will be equal to the y of A, which is 7, minus the y of B, which is 21, over the x of A, which is 3, minus the x of B, which is 10. So 7 minus 21 over 3 minus 10 gives me 2. Now that I have the gradients, I am going to substitute the points in. All right, so I'm going to have two methods here. So method 1, I'm going to use y equals mx plus c. Method 2, I'm going to use the new formula that I've just told you about in a minute. So the two methods that I'm going to use, the first one, I'm going to use the formula y equals mx plus c, and the second one, I'm going to use the new formula, and you're going to see that we get the exact same answer, and we're able to determine the equation of the straight line. So we started by getting our gradient, so we have our gradient being 2. So we can use either coordinates A or B. So I'm just going to use A's coordinates, which are 3 and 7. And I'm going to substitute that into my formula. So y is equal to mx plus c. So I have the m, so that's the m that I'm going to use there. And now I've got an x coordinate, which is 3, so I'm going to put that in place of the x, and I've got a y coordinate being 7, so I'm going to put that in place of the y, and I'm going to determine c's value. So 7 is equal to, m is 2 times x, which is 3, plus c. So 7 is equal to 2 times 3, which is 6, plus c. So therefore I'd be able to say that c is equal to 7 minus 6, which is 1. So I would therefore conclude that y is equal to m to x plus c, c is 1. So now I've taken this 1 that I've just calculated here and I've put it there. So the formula y equals mx plus c, we have to determine m, we have to determine c, and then you put it into your formula. So now we have the formula, or the equation of this straight line, being y is equal to 2x plus 1. If I look at my second formula, I'm still going to use A's coordinates. Now we could use B's coordinates, but I'm just using A also because A's coordinates are smaller. So this is going to be y minus the y of A is equal to m, the gradient, into x minus the x of A. So y minus 7 is equal to 2 into x minus 3. So I can say that y is equal to, I'm going to start by multiplying this 2 into the bracket. 2 times x is 2x. 2 times negative 3 is negative 6. And I'm going to take this negative 7 across, and it's going to become positive 7. So therefore, y is equal to 2x minus x plus 7 is plus 1. So you can see that either method results in the exact same answer. The next question says, determine the equation of the straight line which is parallel to the line y equals minus 2x plus 8 passing through the point A, 3 and 7. So we have the line being parallel to. So we want the equation of the line that's parallel. Now if it's parallel, then that means that these gradients are going to be equal. So parallel lines, therefore equal gradients. All right, so the line parallel to y equals minus 2x plus 8 will have the same gradient as that line because it's parallel, which means that the gradient will be negative 2. So now I'm going to take a's coordinates, which are 3 and 7, and I'm going to substitute it in. Now I prefer the other formula because the other one just kind of cleans it all up and we don't have to remember to put the c back in and the m back in, so I'm just going to use that one. But remember, you can use whichever one you want, so you can try it. I suggest that you actually try using the other formula as well and see that you get the same answer. So I'm going to take y minus the y of a equal to m into x minus the x of a. So y minus 7 will equal the gradient, which is negative 2, into x minus 3. So y is equal to this negative 2 jumps into that bracket. Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. And the negative 7, when it goes across, becomes a positive 7. So therefore, y is equal to negative 2x plus 13. So that means that the equation of the line parallel to y equals negative 2x plus 8 that passes through the point A, 3 and 7 is equal to negative 2x plus 13. The next question says, determine the equation of a straight line which is perpendicular to the line y equals a third x minus 2 with a y-intercept of 6. Now I'm going to use the other formula, but what I'm going to notice is that these two lines will be perpendicular to each other. And if I have perpendicular lines, then that means that the gradient of line 1 multiplied with the gradient of line 2 would equal negative 1. So over here, they've given me the gradient of line 1, which is a third. So that times the gradient of line 2 would equal negative 1. Now obviously you need to get into the habit of being able to do this in your head, the perpendicular gradients. However, to just wrap your head around it the first time, just think about that like a normal equation. If you had a third times a gradient equal to negative 1 and you want to get that gradient by itself, all you're going to do is you're going to divide both sides by a third. And that will give you the gradient of line 2. Negative 1 divided by a third is negative 3. So now I have the gradient being negative 3, and they gave me the y-intercept being 6. So I'm going to use the equation y equals mx plus c. C is the y-intercept, and the gradient is what I just determined now because the lines were perpendicular. So therefore it means that y is equal to negative 3x plus 6. The last two questions I'm just going to link together. Determine the equation of a straight line which is parallel to the x-axis and passes through the point 5 and negative 7, and parallel to the y-axis and passes through the point 5 and negative 7. So both of these questions are very similar. So I just want to quickly discuss them. So if I had the point over here, let's say that this is the point 5 and negative 7. Then that means that over here on the x-axis, I would have a positive 5. And on the y-axis, I would have a point here being negative 7. So a line parallel to the x-axis, so I'm going to identify the x-axis. There's the x-axis, it's in purple. if I have this horizontal line, that means that anywhere on that horizontal line, the x coordinate would be able to change. So over here, I have an x coordinate of, say, 5. Over here, I could have an x coordinate of, let's say, 4. Over here, the x coordinate would be 0. Over here, the x coordinate could be negative 8. However, over here, the y coordinate is negative 7. Over here, the y coordinate is negative 7. Over here, the y coordinate is negative 7. Over here, the y coordinate is negative 7, and I'm pretty sure that you get the point. So that means that anywhere along that line, that horizontal line, the y will have a value of negative 7, which means that this equation has the equation y equals negative 7. Similarly, if I were to highlight the y-axis in, let's say, blue, then this point, if I have a line parallel to the y-axis, then it means that the line would kind of go up like that. All right? And that would have an equation x equals 5. Because irrespective of where I go on this line, the x coordinate will remain a positive 5, whereas the y coordinate is changing. So basically, all my vertical lines have the equation x equals something, whatever it is, wherever it is on the Cartesian plane, and my horizontal lines have an equation y equals, and wherever it is on the Cartesian plane. Now we're going to be talking about the angle of inclination. And the angle of inclination is an angle measured between 0 and 180 degrees. The angle of inclination is measured in an anti-clockwise direction from the x-axis or from a horizontal line to a straight line. There are two things that you have to remember with the angle of inclination, and they go together because, you know, I like to link things together. So, positive gradients, acute angle. Negative gradients, obtuse angle. The angle of inclination is tan theta is equal to the gradients. Now remember, tan is a relationship or a ratio between the opposite and the adjacent sides. Tan is on our calculator. So we have tan on our calculator, the same as pi, the same as sine, the same as cos. We have those on our calculator, which means that tan theta equals m, or the gradient. If we're given the angle of inclination, then we're able to calculate the gradients. Alternatively, if we were given the gradient, we would be able to calculate or determine the angle of inclination, or the alpha. Alpha, beta, delta, gamma, any of the letters, all right? By using our second function, or our arctan. Determine the value of beta, the angle formed by lines AB and BC in the diagram below, if the gradient of line AB is a half, and the gradient of line BC is negative 1/3. When I started talking about the angle of inclination is measured anti-clockwise from the x-axis or from a horizontal line. Now, we can see over here, this beta that we are being asked for is floating up in the air, which means that we're not going to use the angle of inclination formula in order to determine the beta. Now, what I like to remember is that whenever you're working with your analytical geometry and you're working with angle of inclination, it's always helpful to remember that the exterior angle of a triangle is equal to the sum of the interior opposite angles. If I label this over here as theta, and I label that over there as alpha, then I would be able to say that in triangle ABC, theta is equal to alpha plus beta. Why? Because it's the exterior angle of the triangle. So that means that I can calculate alpha, I can calculate theta, therefore I can calculate beta. So we're going to start with alpha, and as you can see over here, that alpha is the angle of inclination of line AB. All right? So that means that tan alpha will equal the gradient of AB. So I'm going to be able to calculate alpha. All right? And then also, I will be able to say that theta is the angle of inclination of BC, which means that tan theta is equal to the gradient of BC. So now I'm going to be able to calculate theta. which is then going to enable me to calculate beta. All right, so tan alpha is equal to the gradient of AB, and they told us that the gradient of AB is a half. So that means that tan alpha is equal to 1 over 2. Now, in order to get an answer for that, I'm going to second function or arctan. So that means that on your calculator, you're going to push shift and then your tan button. So when you push shift and then your tan button, then you get arctan. And then you're going to type in your fraction of a half or 0.5. Therefore, alpha is equal to 26.57 degrees. So this is the length that I was talking about earlier. The gradient of AB was positive a half. So that means that the angle of inclination was an acute angle. Now with the next one, line BC, I have tan theta equal to the gradient of BC, which is negative a third. So now we have a negative gradient, which means that we're going to have an obtuse angle. Now, an easy way to work with this is to work with a reference angle. So what we're going to do is we're going to say RA for reference angle, okay? And now instead of typing that negative into your calculator, you're just going to do arctan a third. So leave the negative out. Okay, so you're just going to leave the negative out. And when you leave the negative out, you get your reference angle being 18.4349, etc. Okay, so now I can say that therefore theta is equal to, now that reference angle that I've got is going to help me by saying 180 degrees minus the 18.434, and that's going to give me my theta. So therefore theta is equal to 180 degrees minus the 18.43, and I get an answer of 161.57 degrees. Now you can see that I had a negative gradient, which means that I have an obtuse angle. Another way you could have done this is that you could have typed the negative into your calculator and you just needed to add 180 degrees afterwards, because you'd be able to know that your answer can't be negative and your answer has to be between 0 and 180 degrees. Either way, you're going to get to the exact same answer. All right, but we're actually looking for beta. So if I were to take this formula here at the top that I had, theta equals alpha plus beta, because the exterior angle of a triangle is equal to the sum of the interior opposite angles, I would be able to conclude that beta will equal theta minus alpha. So therefore, beta is equal to 135 degrees, because I took the alpha and I subtracted it from the theta, and I got 135 degrees for beta.